A few thousand years ago, somebody was sitting around saying, I'm so tired of carving 3 plus 3 plus 3 plus 3 in the sand, I'm going to invent multiplication. And they did. That's what 4 times 3 means. Multiplication is just addition by the same number simplified. And then a few centuries later, somebody said, I'm tired of writing 3 times 3 times 3 times 3 in the sand. I'm going to invent powers, 3 to the 4th. That's what that means. So, this is 3 to the 4th. It's called a power. That is the exponent, and the 3, the number you keep multiplying by, that's the base. Now if you have a coefficient in front, like 5 times 4 3's multiplied together, then it's 5 times 3 raised to the 4th power. That's a coefficient, 3 is the base, 4 is the exponent. Alright, so let's expand this using multiplication. We know that 2 to the 3rd is 2 times 2 times 2. We know that, so that would be worth 8. Now, what if we expand this and use multiplication? 2 to the 3rd means you're multiplying 3 2's together. We're going to multiply that by 2 to the 2nd. That's multiplying 2 2's together. Now, in the end, when altogether we have 5 2's, so this is going to be 2 to the 5th. Now, exponents, they tell us how many bases to multiply. That's really important. So here, what do you get when you take 2 to the 4th times 2 to the 3rd? The answer? Well, there's 4 2's multiplied by here and 3 more 2's here. So altogether, there's 7 2's. If you don't believe me, there's 4 2's being multiplied by there and 3 2's here. So 2 to the 7th power. There's 7 2's altogether. So here it is, the first of 2 properties, the product of powers property. This rule can look ugly. A is like some constant, some number raised to the m. Like A is 5 and m is 3, multiplied by 5 to the 4th. The rule we can use is just to add the exponents to keep track of how many 5's are being multiplied. So we get 5 to the 7th. We're going to add the 3 plus the 4 and get 5 to the 7th. So if we see a problem like this, altogether, how many 3's are being multiplied? 8. How many x's are being multiplied? We can do variables too. Variables are just numbers. There's 2 x's multiplied here. So this is x times x. And there's another 4 x's here. So x times x times x times x. Altogether, 6 x's are multiplied. We add the 2 plus the 4. And we get x to the 6th power. Alright, now if we expand this, what if we take 2 squared and we cube it, raise it to the 3rd power? Let's think now. Remember, exponents tell us how many things are being multiplied. 3 things are being multiplied. The base that goes with this exponent is 2 squared. So 2 squared is being multiplied 3 times. But what is 2 squared? There's 2 2's multiplied. That's 2 squared, that's 2 squared, that's 2 squared. Altogether, 6 2's are multiplied, so it's 2 to the 6th. We need a power of a power rule. So if we take the power of this power, you multiply exponents together. Here's the rule. If you have some number like 5 raised to the 3rd, and then that whole thing is going to be squared, just multiply the exponents together. Multiply the 3 times the 2 to get the 6, because 5 to the 3rd raised to the 2nd means there's a 5 to the 3rd times a 5 to the 3rd being multiplied. But the rule is to multiply the exponents. How many 2's ultimately are going to get multiplied by here, or multiplied together? And the answer is 2 to the 8th. There's 4 of these 2 squareds being multiplied. So altogether, it's 2 to the 2 times 4, it's 2 to the 8th power. How many x's are multiplied? Well, 3 sets of x squared would be x to the 6th. Multiply the 2 times the 3, get x to the 6th power. Now we can do a bunch of variables. How many x's? Remember, the exponent tells us how many things are multiplied. 2 x's are multiplied by here, 3 more here, and 4 here. Altogether, there are 9. We add the exponents together, and this would be x to the 9th power. So that's an intro to multiplying and working with exponents.